In the last video, we talked about how to graph two variable linear equations, variables that have both an x and a y. And so in this video, we're going to go over 6 problems involving graphing linear equations. The first problem we're going to go over is we're going to want to find the x and y intercepts of this graph. It's pretty simple, and then we'll get more involved as we go along. More complicated. But the first graph is going to look something like this. Here's my y-coordinate. Here's my x-coordinate. And then I'm going to have my line going from here to, well, right about there. A little bit off, but right about there. As expected, since I'm a math major, I'm not a good drawer. So, be kind. And so here we want to find the x and y intercepts here. Now, I think this will be pretty simple for some of us, so I'm just going to go over here's the x, here's the y. Our x-intercept can be found along our x-axis, and so if I were to count each of these tally marks out, we have 1, 2, and then 3. This point right here in lime green is our x-intercept, and that is at the point 3, 0. Okay? Remember, when you have points, you always do x first, then y. Okay? And so our y value in this case is 0. We're not moving anywhere on the y-axis. Now on to our other problem. Our other intercept, the y-intercept. It is 1, 2. And so here our y-intercept is 0, 2. Okay. That is the first problem. We'll go on to the next problem here. Our next problem will be find the x and y intercepts and then graph the equation. So we're going to start off with an equation, and then we want to graph it. Okay. I'm going to draw out what we have first. I'll give my equation, which we have y is now equal to 5x. And here we want to graph it. We need to find the x and y intercepts, and then we also need to graph it. Now, in order to find the x and y intercepts, we need to know when x is 0 and when y is 0. So the best thing we can do here is use a t-chart. So if I have x on one side, y on another side, if I plug in 0 for x, this will give me my y-intercept. Okay, so now all I have to do is plug in 0 for x and then solve for y. So 5 times 0 would be 0 in this case. So my y-intercept is 0, 0. Additionally, if I plug in 0 for y, I will then get my x-intercept. Okay, and what we're going to realize here is if I plug in 0 for y on the equation here, I'm going to get 0 is equal to 5x. I'm going to divide both sides by 5. And I get 0 is equal to x. And so in this case, my x-intercept and my y-intercept are the same, 0, 0. And so that means if I were to graph this problem, my x and y-intercept is at the origin, 0, 0. Okay. Now I still have to graph the line, so I'm going to leave a little bit of room. Here's my x-axis, here's my y-axis. Okay. And so we have y is equal to 5x, And now I want to know, let's just get one more point, because if I get one more point, then I can graph this equation. So I want to know, what is the value of y when x is equal to 1? Well, that means we plug in 1 for x. 5 times 1 gets us 5. And so then that means, in my line now, if I move out one spot on my x-axis, I now need to move up 5 on my y-axis. 1, 2, 3, 4, 5. There's my other point, which is 1, 5. And now I need to draw a line in between them, connecting the dots. Something like that. All right. That is problem number 2. We'll move on to problem number 3 now. Problem number 3 is going to be very similar, except we're just going to be dealing with a different equation. We still want to find the x and y intercepts, and we still want to graph it. And in this case, our problem is going to be y is now equal to negative 2x plus 4. Okay. Similar to what I did before, I'm going to start with a t-chart. I'm going to have x, I'm going to have y. I want to know my x-intercept when x is 0. I want to know my y-intercept when... I want to know my y-intercept when x is 0, and I want to know my x-intercept when y is 0. Gets confusing. And I'm going to choose one more point afterwards. But I'll first start off with my x and y intercepts. Okay. So let's solve for y when x is equal to 0. So that means for this equation here, I'm going to get y is now equal to negative 2 times 0 plus 4. Negative 2 times 0 is just 0, so I'm going to get y is equal to 4. Okay, there's my y-intercept. And now I want to know where my x-intercept is, so I'm going to plug in 0 for y. And so that means I'm going to have 0 is now equal to negative 2x plus 4. I'm going to subtract 4 to both sides. I'm going to get negative 4. Whoops. Do that in white. I'm going to get negative 4 is equal to negative 2x. Now I'm going to divide by negative 2 to both sides. And I'm going to get 2 is equal to x. Okay. So now I have my 2 points. I have my x-intercept and my y-intercept. Now, additionally, I can choose one more point if I want to. I don't have to, but I will. So I want to know what happens when x is equal to 1. Now I'm going to do a little bit of mental math here, so you can follow along if you want to. I'm going to plug in x is equal to 1, so I'm going to get negative 2 times 1 plus 4. Negative 2 times 1 is negative 2 plus 4 now. Negative 2 plus 4 is just positive 2. And so that gets me a third point. Having more points is always better, especially if you're graphing. And so now let's get down to the final problem here, and let's go ahead and graph our equation. Oh, the final portion of this problem, I should say. So here's my y-axis, here's my x-axis, and I need 1, 2, 3, 4, 2. Okay. And so looking at my my points up above, my y-axis is at 0, my y-intercept is at 0, 4. So that's going to be right here. That is 0, 4. And then my x-intercept is at 2, 0, which is way down here. And then if I pick a point in between, it was at 1, 2, which is right about here. Okay, now I just need to draw a line between these three dots. There we go. Okay. Now, one thing we have to note here, and this can also just serve as a check if you want to. Notice in the in the problem we had a slope of -2. And so with that slope of -2, we would expect that in our graph down here at the bottom that we would be going down. And it turns out that yes, our line is going down, our slope is negative, and so that means we're on the right path. You can always use that as a check of the work you're doing. Okay, we're going to move on to another problem now. Same rule applies. We need to find the y-intercept, the x-intercept, and graph it. And our problem in this case is x is equal to 4. Okay. Well, this is kind of tricky. When I draw my t-chart x and y, do I have any y values? No. I don't have any y values. And so, well, technically I do have a y value, I just can't plug in anything for y. Because if I plug in 1 for y, or 2 for y, or 3 for y, the value of x is always going to remain the same. It's 4, no matter what I choose for y. Okay? And that's very important, because when we go to graph this problem, which I'll do right now, here's my y-axis, here's my x-axis. I'm going to go at 1, 2, 3, 4 spots. My graph is right here. No matter what I choose for y, x is always the same. So in this case, my x-intercept, my x-int, as I will abbreviate it, is 4, 0. Okay, it's right here, 4, 0. But do I have a y-intercept? No, I do not. In this case, this problem simply does not have a y-intercept. I don't know exactly how your teachers are going to want to phrase this, or how your book is going to want to phrase this. Some of them will say it does not exist. Others will say not applicable, or NA, or none. There's multiple ways you can phrase that. I'm just going to choose NA, or not applicable. In very formal speaking, technically it does not exist. Would probably be the most formal way to say that. Okay. We have 2 more problems to go over. We'll stick with our same rules. We want to get the y-intercept, the x-intercept, and graph it. Our next problem is going to be a bit more tricky. It's going to be 6x plus 3y is now equal to 18. Okay. Now, a couple of things here. One, you could just start off with a t-chart and solve for points. You could get x and y points. That's very possible. In fact, it's technically the simplest way to go about doing this. However, whenever I'll graph equations, I like to put them into slope-intercept form, y equals mx plus b. I like to solve for y, because it allows me to know what the slope is and allows me to know what the y-intercept is. Okay, and so that's what I'm going to do here. What that means is I'm going to start off by subtracting 6x to both sides. I'm going to get free y is equal to negative 6x plus 18. And then I'm going to divide both sides by free. Or technically multiply by 1 over free, but it doesn't really matter. So I'm going to get y is equal to negative 6 divided by free is negative 2 plus 6. Okay. Okay. Now that I have my equation in slope-intercept form, I could immediately find that the y-intercept is this value right here. And so that means my y-intercept is 0, 6. From there, you could also use the slope to determine another point, but I'll just use the t-chart that we have. So I know that my y-intercept is 0, 6. And so that means when I plug in 0 for y to get my x-intercept, I'm going to get 0 is equal to negative 2x plus 6. I'm going to subtract 6 to both sides. Going to get negative 6 is equal to negative 2x. Divide by negative 2. And a negative divided by a negative is a positive, remember that. So we get free is equal to x. Okay. And so that means for my x-intercept point, I get free, 0. Okay, now I just have to go ahead and graph those. So I have 0, 6 and free, 0 that I have to graph. And then draw a line between them. So if I get my graph going, one, 2, 3, 4, 5, 6. 1, 2, 3. Here's my x, here's my y. I have 1 point at 0, 6. I have 1 point at free, 0. And now I can graph them together. Just about like that. Whoops. There we go. Okay, and additionally, since we have it in slope-intercept form, you can see that the slope is negative. And that lines up with our graph, which it's pointing downwards. All right, we have one last problem to go over. Our last problem will be y is equal to 4 plus 4x. All right, this one is slightly tricky, just in that it's flipped. So in order to get into slope-intercept form, all we have to do is just switch these two values. And so if I rewrite it again, I'm going to get y is equal to 4x plus 4. Yep. Use my t-chart. Okay. For my y-intercept, obviously it's here in my slope. It's 4. Sorry, from my slope-intercept equation, It's the b value, the last value, which is 4. And then for when y is equal to 0, we'll have to solve for that. So we're going to get 0 is equal to 4x plus 4. I'm going to subtract 4 to both sides. I'm going to get negative 4 is now equal to 4x. And then dividing both sides by 4 gets me negative 1 is now equal to x. Okay. So my x-intercept is negative 1, 0. My y-intercept is 0, 4. And now I have to graph those two. Give a little bit better spacing here. Okay. So negative 1, 0 is right over here. It's a negative value on my x-axis, so it's to the left. And so we get negative 1, 0. And then 0, 4 is up here. I always get those confused. 0, 4 is up here at the top with my y-axis. And then drawing a line between these two. We get this equation. All right. Awesome. Next video will be on linear inequalities. And so we're actually going to see that we can also graph linear inequalities. And it's very similar to how we graph these problems, except we're going to be doing some shading, and we might have a dotted line instead of a solid line. But we'll talk more about that in the next video.